All right, so this whole lesson is about solving systems of equations by graphing. So before we actually get to a system of equations, I want to take a minute to review how you actually graph a linear equation. So the first thing is that you need to have your equation in slope-intercept form. Slope-intercept form is this thing down here that says y equals mx plus b. So I need to take this equation that I'm putting a box around and I need to rewrite it so that it's set equal to y. And basically what we're going to do here is solve for y. So I'm going to copy it down. 2x plus 3y equals 12. The first thing we're going to do is subtract our x term. So I'm going to do minus 2x on both sides of the equation. And I'm going to write what I get up here. So the 2x's cancel out on the left, leaving me just with 3y. And then even though I would usually write 12 minus 2x, I'm going to put the 2x first, the negative 2x first, because I want my x term to come first. And then the last thing I have to do is divide everything by 3. Now we're dividing both sides by 3. Normally I would say, you could put down like one big line and put a 3 underneath. But the reason I don't really like to do that is because then sometimes you forget to divide both terms. So I like to split it up where I divide every single term individually by 3. So final answer here. The 3's would cancel, leaving me with just y. And then negative 2 over 3x, nothing simplifies there. And then 12 over 3 is, if you divide it, is 4. So this right here is my equation in slope-intercept form. Now that it's in slope-intercept form, we can identify the slope and the y-intercept. The variable that we use for slope is m. So my slope is going to be the number in front of x. So in this problem here, our slope is negative 2 over 3. And then the y-intercept is the constant number at the end. So that's your b value. And in our problem, it's 4. All right, so step 3, it says to plot the point 0, b. So we just figured out from step 2 that our b value is 4. So I'm actually going to plot the point 0, 4, which is just plotting the number 4 on the y-axis. So here's the number 4. I'm going to put a point right there. And then from there, step 4 says to count the slope from that point I just did. So remember that slope is rise over run. So I'm going to rise negative 2, which actually means we're going to go down 2. And then we're going to run, which means left and right, positive 3. So this negative here only goes with one of your numbers, and I'm going to choose to put it with the 2. So I'm going to, from my point, my blue point, I'm going to go down 2, and then I'm going to go right 3, and I'm going to make another point. And once you have 2 points, that's all you need. So now I'm going to just connect these dots, and we are done. So that's how you graph a line. Now, just a couple reminders. If you have a line that is just x equals, so for example, if you have a line that is x equals 5, that would be a vertical line through 5 on the x-axis. So I'm going to draw you a quick sketch here. So I would go over to 5 on the x-axis, and I would draw a vertical line. If you have a y equals line, that is a horizontal line. So let's say I have y equals negative 1. I would go to negative 1 on the y-axis, and then it would be a horizontal line that goes through the y-axis. So it's opposite of what what your axes are. So usually your x-axis is horizontal, but an x equals line is vertical. So it's the opposite of what you think. Now we're actually going to solve a system. So we're going to have 2 equations that we're going to graph, and the solution will be where the 2 lines cross each other. So there are some steps here that we'll follow, but you can kind of just look back at them for reference. I'm not going to read them. So it says to solve this linear system graphically and then check the solution algebraically. So we're going to get our answer using the graph, and then we're going to plug that answer back in and check to see if it works. So both of these equations are already in slope-intercept form. So I'm going to graph this top equation in red. For the top equation, my slope, and remember slope is the number that's in front of x. Since there's nothing there, we can assume it's a 1. It's actually a negative 1. And when we do slope, it's nice to have it as a fraction so that we can think of it as rise over run. So if that helps you out, you can always put every whole number over 1, and that makes it into a fraction. And then my y-intercept would be negative 2, so that's my b value. So I'm going to go over to the graph now. I'm going to plot the point, my y-intercept at negative 2, and then my slope is negative 1 over 1. So I'm going to go down 1 and right 1, or I can go up one and left one. You have to go one positive direction and one negative direction. And I'm actually going to do both. And the reason is because when I do this, so I'm going to go down one and right one. When I do this, I want to see where my lines cross. So as many points as I can have as possible, it's going to make my life easier to figure out the exact point where the two lines cross. So now I'm going to connect all the dots. For some reason, my lines were drawing in the wrong spot. Okay, so that's the red one. Now I'm going to do the next one in blue. So again, it's in slope-intercept form. I don't have to rearrange it like our previous example. The slope would be the number in front of x, so that would be 2/3. And my y-intercept would be your constant number, or 3. So I'm going to go over to my graph, and I'm going to put my y-intercept at 3. And then both of my my rise and run are positive. So I have to go up and to the right. So for example, I'd go up 2 and right 3 and make a point. That would be both positive directions. Or I can go down 2 and left 3. And you can see that when I went down 2 and left 3, I had to draw a blue point over an existing red point. So that point that I had to, where there were two colors, that is my solution. So the solution to this problem, I'm going to put it in purple. I'm going to put a purple box around it. It's that number right there, that ordered pair, which is -3, 1. So that's my answer, -3, 1. Now it says to check the solution algebraically. So this part, it's not like a necessary step every single time you do a problem, but I want to show you how you can check your answer to make sure that you are correct. So in order to do that, I'm going to take this ordered pair and I'm going to plug it back into my equations to make sure that both sides of my equation come out equal. So everywhere I see a y, I'm going to put a 1. Everywhere I see an x, I'm going to put a -3. So for the red equation, I'm going to write y equals, but instead of y, I'm replacing y with 1. And then negative x would be -3, and then -2. So -3 is actually positive 3, and then 3 minus 2 is 1. So you see how we came out with 1 on both sides of the equation? That means that this point checks out for equation 1. Now I'm going to do the same thing for the blue equation, and as long as it works out to have the same answer on both sides, that means we're good. So again, I'm doing y equals, and then 2/3 times x plus 3. All right, so this fraction here, the denominator of 3 and the -3 that I'm multiplying by, those are going to cancel each other out. But this negative is still going to be there. So 2 times a negative is -2, and then plus 3. And -2 plus 3 is 1. So I get 1 on both sides again. So I solved the equation. My actual solution is the thing that's in purple. But then the red and the blue checks are there to make sure that we actually had the correct answer. This example we're going to do is the same as the previous example, number 2, but the difference is example 2, all of my equations, or both of my equations, were already solved for y, and now we have to solve these and put them into slope-intercept form. So it's going to be a little bit of extra work before we can start graphing. So I'm going to do my first equation here in red. I'm going to copy down the equation, and now I have to get y by itself. So this is always going to be a two-step process. You're going to add or subtract your x value and then divide by whatever your coefficient is on y. So the first thing I'm going to do is add my x value to both sides, and I'm adding because it was negative. Oops, my color changed here. So then I would have y equals 2x plus 3. Now normally I would say you'd have to do your second step, which would be to divide by your coefficient on y. However, our y is already by itself, so this was actually a one-step deal. So this right here is going to be what I'm actually going to graph in red. So I'm going to go up here and make a point on the y-axis at 3. That's my y-intercept. And then my slope here, which I'm actually going to write out, my slope is 2, but sometimes it's helpful to see it as a fraction. So since it's a whole number, I can always put 1 underneath it, and that way I can see my rise and my run. So they're both positive, so I'm going to have to go up 2 and right 1, or I can go down 2 and left 1. So either 2 positive directions or 2 negative directions. And I like to make as many points as will fit on the graph, and that way I know when I draw my second line, I'll be able to see exactly where the two things cross. So here is my red line. Now I'm going to do the same thing for the bottom one, which I'm going to do in blue. So I'm going to rewrite the equation and then we'll solve. So First step is always to add or subtract your x term. So I'm going to add 4x to both sides. So I have 2y equals 4x plus 6. And then this one does have a coefficient on y. So I'm going to divide every single term by 2. So that leaves me with 4 divided by 2 is 2. And then 6 divided by 2 is 3. So this is my new blue equation. So over here, my slope is 2. And my y-intercept is 3. Now again, with the slope, I'm going to say 2 over 1, and that way we can actually see the rise over run. So my y-intercept is 3. Okay, so I can see that I have an overlapping point. And then I'm going to do my slope. So I'm going to go up 2 and right 1, same point, down 2 and left 1. So you'll notice that all of the blue points that I'm writing go exactly over all of the red points that I had already written. So what's happening here is we have like a special case of a system of equations. They're actually the same line. So a solution is when I have a point that overlaps, but since all of these exact points are going to overlap because they're the exact same line, I have infinitely many solutions. So if they cross in one place, we have one solution, but if they cross every place, we have infinitely many solutions. So I'm going to write infinitely many solutions. And sometimes I'll abbreviate this IMS, just so I don't have to write out the whole thing each time. But that would be your final answer. So it's not an ordered pair, it's just infinitely many solutions. Everything works. All right, example 4. We are going to have to rearrange that first equation, the top equation, because it's not in slope-intercept form. So I'm going to copy it down over here, 3x minus 2y equals negative 8. And as usual, we have to add or subtract our x term first. So I'm going to subtract 3x from both sides. And that would leave me with negative 2y equals negative 3x minus 8. And now I have to divide by the number in front of y. So divide everything by negative 2. And I would get y equals. Now this 3 over 2, the fraction, the numbers don't reduce, but I have two negatives, so it actually turns into a positive. And then same thing with my 8 and my 2. It's going to be positive because I have two negatives. And then 8 divided by 2 is 4. So this is my new equation for the red line. So I'm going to do my y-intercept at 4. Since my slope is 3 over 2, I would go up 3 and right 2. But as you can see, I would run out of graph. So I'm going to go two negative directions. I'm going to go down 3 and left 2. And I'm going to do that as many times as I can until, oops, I run out of graph. So that one was wrong. I have to go down 3 and left 2. And then I actually run out of graph already. So this is as good as I need to get. And then for my bottom line, the x equals negative 2, remember that when you have an x equals line, that means it's going to be a vertical line. So all I have to do is find negative 2 on the x-axis. So that's right here. And then I'm drawing a vertical line that goes through it. So I can see that this right here is where my two lines cross. So that ordered pair is my solution. And that ordered pair is negative 2, 1. We're going to solve this system graphically. And so in order to do that, we're going to take our top equation, which is already in slope-intercept form. I'm going to identify that the slope is negative 2 and the y-intercept is 5. And I'm going to write my slope as negative 2 over 1 so we can see the rise and the run. So I'm going to go over to the y-axis and mark down my y-intercept at 5. And then for my slope, I'm going to go down 2 and right 1 until I run out of graph. So this right here would be my first line. All right, now my second line is not in slope-intercept form. So before we can identify slope and y-intercept, we're going to rearrange. So I'm going to subtract 2x from both sides, leaving me with y equals negative 2x plus 1. And I don't have to divide by anything because I don't have a number in front of y. So I can go right here now to my slope, which is negative 2, and my y-intercept, which is 1. And again, I'm going to rewrite my slope as negative 2 over 1. So my y-intercept is at 1. And then I'm going to do the same thing where I go down 2 and right 1, down 2, right 1. And then from this blue point, I can also go up 2 and left 1. I couldn't have done that on the red line because I would have gone off the graph. So you'll notice that these two lines are parallel. They're never going to cross each other. They're at the exact same steepness. So when that happens, the solution is that there is no solution. So remember that when you were talking about systems of equations, the solution is the ordered pair where the two lines cross. So a lot of our systems crossed in one place, so we had one ordered pair as our answer. Sometimes we had equations where they were the exact same line, so they crossed everywhere, so we had infinitely many solutions. But this one has no solution because these two lines never cross. So it tells us to check the solution algebraically, but there is no solution, so there's nothing to check. So one kind of trick just to keep your eye out for, if you notice that you have two equations that have the same slope, so these both had a slope of -2, but they have different y-intercepts, that's when you're going to have parallel lines. If you have two lines that have the same slope and the same y-intercept, that means they're actually the same line, and that's when you'll have infinitely many solutions. This is a true or false question. It's asking if a linear system always has a solution. So what that means is every time that you solve a system of equations, are the lines going to cross? And the answer is that it is false. And then it says if it's false, provide a counterexample. If you go back to example 5, that would be a counterexample. So we saw two lines where they were parallel and they didn't cross each other, so there was no solution. So in order to answer this question, to provide a counterexample, we could just give the example that we had for example 5, but that seems kind of boring. So what I'm going to do is write a couple notes here. So first of all, in order to have no solution to a system of equations, you have to have two lines that have the same slope, but they have different y-intercepts. So if we can write two lines that have the same slope, which is, let me write this down, we have y equals mx plus b. So this thing has to be the same, and then this thing has to be different. So I'm going to write my system of equations, y equals. It doesn't tell us we have to put it in a certain form, so the easiest thing to do is to put it in slope-intercept form. So I'm going to pick any slope that I want. I'm going to pick the slope 3. So I'm going to say 3x for each of my lines, and then my b number just has to be different. So I can choose anything. I could say +5 for one of them and -2 for the other one. As long as the b numbers are different and the m numbers are the same, this right here would be a counterexample. So that would be something that shows that the statement that we said was false.